Hello everyone, it's Benny, and welcome back to the Java 2D RPG development series using OpenGL. As always, a quick recap. So, what we've done so far, we set up a game engine, we have players, we have enemies, we have items, we have inventory, we even have basic combat set up. So we've done a lot of stuff so far. So if you've made it this far in the series, congratulations, because we're not that far from actually implementing a game. So, yeah, be prepared for that. But we still have a couple more things to do, and that's what we're going to work on in this video. So first off, in our combat system, our enemy can attack our player all at once, but our player can't attack the enemy back. So, we're going to work on that a bit in this video, and we're also going to work a bit on equipping items, because I think it makes some sense that the player can attack with more than just his fist. Maybe he can pick up a sword or a machine gun or whatever, and just attack the enemy with it. So that's what we're going to work on in this video. So, without further ado, let's go ahead and get started. So, to start off, what I'm going to do is I'm going to give the player the ability to attack. Because it doesn't make much sense for the enemy to be able to attack the player, and the player not be able to attack the enemy back. So, what I'm going to do is I'm just going to go into the player class, which I'm already in, and I'm going to add an attack method. Now, it doesn't really matter where you put this, but I'm just going to put mine right under the getInput method. So, right here, I'm just going to create public void attack. Simple enough, nothing too fancy just yet. But now, before I actually implement anything in the attack method, what I want to do is I want to call this method somewhere. Because it's really not good coding practice to have a method that never gets called, so just right below the getInput method, or excuse me, inside the getInput method, I'm going to test if we're hitting the spacebar. And if we're hitting the spacebar, we're going to attack. So, simple enough, it's going to be done just like every other input we've done. If keyboard.isKeyDown key underscore space, excuse me, keyboard.key underspace, then keyboard dot key underscore space, then we're just going to attack. So if we're hitting the spacebar, we attack. Easy enough. And the first piece of logic I'm going to put into the attack method is just saying system.out.println we're attacking exclamation point. And now if I hit run, you notice I'm still playing like normal. If I get the attention of the enemy starts chasing us. And if I hit space, it's completely destroying our output log with we're attacking. Because we're attacking at about 1,000,000 times per second. Not exactly what I want. So the first thing we're going to do is we're going to add a delay. So, to implement the delay, I'm just going to use the delay class that we created in the last video. So I'm going to go to the top and I'm going to create a new variable for the delay. When did I add a variable for attack range? I don't remember adding a variable for attack range, but apparently I did. So, okay, so I have an attack range and it's set to 48. Okay, I honestly do not remember implementing that. I'm sorry. So, but, yeah, okay. So apparently we already had attack range. Now we need attack delay. Okay. So I'm just going to create a private delay called attack delay. Let's do Control-Shift-I. I really don't remember implementing attack range, but oh well, I'll get over the freakiness. And now in the constructor, I'm just going to initialize attack delay equals new delay. And now we need to pass in how many milliseconds we want the delay to be. I'm going to set it to 500 because that's what the enemy had. So, now that we have the attack delay, which I'm actually going to put above attack range just because it makes me feel a little bit better. Now I'm going to go to the attack method. And actually, I'm not even going to do that. I'm going to do this in the input method. So if we're hitting the space bar and attack delay dot over, so and the delay's over, only then do we attack. So right now we're not resetting the delay, so, and the attack method, I'm just going to go to attack delay, and do attack delay dot reset. And that should... Actually, I'd never actually started the delay, so I need to do that. So, okay. And actually, I really don't need a reset method. I don't even know why I'm using that. So, I'm sorry, I'm a little tired, a little out of it. Haven't worked with this in a while, so bear with me for a moment. Okay, so now, just right below the attack delay, I'm just going to do attack delay dot end. And that should set it to the end. And now that the delay is over, which means we can instantly attack, in the attack method, I'm just going to do attack delay dot start, because we don't need to reset it, we just need to start it. And that should work. So if I hit run, now our enemy can chase us, and if we hit attack, I'm holding the spacebar, and you'll notice it's only attacking once every 500 milliseconds. So good, it's working exactly as intended. So there. But now we need a way of actually doing damage to the enemy. And this is a little bit trickier than it might seem at first, because in our enemy class we already had a target, and that it just chased the target, and if it was in range of the target, it attacked. But in the case of the player, we have a little bit more of a complicated situation, because our player has no one set target. And furthermore, the player can't... It can potentially have many enemies within its target range at once, and it can only be attacking one at a time. So we're going to have to do a little bit more work to get this one working. And that starts by keeping track of which direction we're facing, because if we're not facing towards the enemy, we shouldn't be attacking it. So, that's the first thing I'm going to do. I'm going to check to see if we're facing whatever enemy we're supposed to be attacking. So, the way I'm going to do this is I'm just going to keep track of a private int called facing direction. And in my constructor, I'm going to initialize facing direction equal to 0. And all I'm going to do here is in the move method, I'm going to set my facing direction based on magnitude. And since I'm passing the variables in like this, I can easily do that. So, actually, you know what? Okay, fair enough. I can do it like that. So, if magnitude x is equal to 0, and magnitude y is equal to 1. Now, the reason it's 0 and 1 is because when I'm moving forward, I'm passing in 0 and 1. So this is testing if we're moving forward. If we're moving forward, then I'm going to set facing direction equal to 0. And that's just going to represent we're facing forward. So that's not that hard. Now I just need to do the exact same thing for the other 3 directions. So, 1, 2, 3. There. Now, in the case of backwards, it's going to be -1 in y, so that's going to set facing direction to 1, and this one's going to be 2 and 3, so we can just go ahead and change that immediately. Now, this one, I'm going to test if we're moving left, so according to our handy move method, or move call, I should say, we know that's -1 and 1, or -1 and 0, excuse me. So if we're doing that, then we're going to move left, which is going to be 2, and we're going to pass in 1 and 0 if we're moving right, which is 3. So there. We now have a way of keeping track of which direction we're facing, but that doesn't help us much just yet. So we're going to have to do a little bit more than this. And the next step to getting it done, really, is just finding if there's an enemy within attack range. Because if there's an enemy within attack range, and it's in front of us, then we're going to be able to attack it. So that's the logic here. Now, we don't really have a method of detecting if an enemy is in front of us. So what I'm going to do is I'm going to go to the main class. And now, if you remember from when we implemented the enemy's attack system, or rather the look system, this is where we created the sphere collide method, which we used to find all players or potential targets within a sphere of the enemy. We're going to do something a little bit similar here. But instead of a collision system, I guess you could say, well, as you know, it is going to be based on collisions. I should not say that at all, but instead of a sphere collide, we're going to do a rectangle collide. So, public static is going to return array list of every game object within the rectangle. It's be called rectangle collide. And that's just going to return, excuse me, now we need to take in a couple parameters. We just need to take in x1, float y1, float, and the float of... Actually, that's all we need to take in, isn't it? Okay, fair enough. So we're going to take in x1, y1, and then float x2, y2. Float y2. There we go. I'll get there, don't worry. Okay. And there. Okay, now we finally have the rectangle collide method. And what we're going to return is we're just going to return game.same method, except it's going to except the game is what's going to actually handle all the logic for it. Because if you remember, the purpose of the main class is to act as sort of the management system that manages everything, so the game's what's actually going to do the heavy lifting here. Now, I believe that's the error, that we just don't have it implemented yet, so I'm going to go to the game class, which is under com.base.game, to the game class, and I'm going to implement a new method right under the sphere collide method. It's going to return a public array list of game objects, and the method is going to be called rectangle collide. Now this takes in, again, float x1, float x2, actually, did I do float x? Hang on, I'm going to see which order. Okay. I had the parameters slightly out of order, so I'll just redo that. Float x1, float y1, float x2, and float y2. And there. So, now all we have to do is we have to perform the actual rectangular collision. This method starts off a lot like the sphere collide method. First, we need an array list of game objects, called res for the result, and this is just going to be the resulting array list that we're creating, and we're going to return this at the end of the method. And we're just going to initialize this to a new array list of game objects, if I can spell, and at the end of the method, we're just going to return this list. And the middle is where everything's really going to happen. In the middle, just like the sphere collide method, we're going to go through every game object, geo, in objects, so every object in the game, and we're going to test if our rectangle is colliding with that object. And if it is, we're going to add it to the list. If it's not, we're just going to skip over it. Now the issue comes here where we don't really have a method for testing for collisions between a rectangle and a game object. We just have, if you look in our physics class, a method for testing collisions between a game object and a game object. So I'm just going to change this around a bit. I'm going to copy this, and I'm going to create a method that tests for collisions between rectangles and game objects. It's going to take a rectangle, R1, and a game object, Go2. I'm just going to delete this rectangle 1 right here, and then I'm going to do the exact same thing. And in fact, to enable code reuse, in here I'm going to delete the second half in the original check collision method. I'm going to delete the second half of the code, and I'm just going to return check collision between, I'm going to just move this because we don't need it in a variable form anymore, between a rectangle and game object 2. And that should essentially just create a rectangle from the first game object and then perform the same collision check. So now we've expanded our code and, in my opinion, simplified it a little bit. So, there. Now, all we have to do is, in here, we need to create a rectangle from these 4 variables. Now, I believe it's... Okay. So, first off, the way the rectangle class works is it takes in size in x and not direct coordinates, so we're going to need to convert these coordinates to size. So, I'm going to create a temporary int called sx, and it's going to just equal x1 minus x2, an int sy, which equals y, yeah, y1 minus y2. And actually, these will need to be floats because I'm taking in floats. So I'm going to change these to floats. And now we have sx and sy. And now we can create a rectangle. So I'm just going to create a rectangle called collider. Yeah, that makes sense. Rectangle called collider. And it's going to be a new rectangle. And it's going to take in x1, y1, and then sx and sy. And that should create a rectangle with the appropriate dimensions. Now we just need to import it, so I'm going to do Control-Shift-I. And make sure you're importing java.auth.rectangle and not the lightweight Java game library rectangle. So there. And now we're getting an error. No suitable constructor because we need to cast them to ints. So I'm going to cast them all to integers in the constructor. So just cast them all to ints. Just like we did in the physics class. So, and now that we have the collider, we can actually perform the calculation. So, for each game object, geo and object, if physics dot check collisions between collider and geo, which it was smart enough to figure out on its own. So if this is not equal to null, that means that they did collide. Then we're going to do res.add geo. And then this should perform the rectangle collision exactly as we expect. So now we have a method for spherical collisions and rectangular collisions. Easy enough. Now we can finally go back to the player class and actually start using these methods to test if what we're attacking. So, instead of printing out we're attacking, although in fact I will leave this here just so that we have it, in here we're going to make use of the new method we just created. So, in here we're going to test. Well, first off, we're going to create an array list of game objects. And this is just going to be all objects within the attack range. So, I'm going to call this, I'll just call it objects. And it's going to be equal to main. Actually, I'm going to leave it like this for a moment because the way we're going to do the collision of the rectangle, if I hit Control-Shift-I to import, the way we're going to handle the rectangle collision will depend on which direction we're facing. Because we want a rectangle that encapsulates what's in front of us if we're facing forward, but we want a rectangle that encapsulates what's behind us if we're facing backwards, for example. So that's what we're going to do right here. But first off, I'm actually going to change facing direction a little bit. I'm going to change it to work based on constants. And the reason for that is if I want to add more directions, like diagonal, for instance, that way, at least I don't have to go through and change all the number systems or whatever. So, I'm just going to create a public static final float, not int, and this will just be called forward, and that will equal 0. I'll just do this for all the directions. So forward, backwards, left, and right. So forwards, backward, left, and right. And this will of course be 1, 2, 3, and 4. There we go. We have forward, backwards, left, and right. And in here we just need to change the initialization to forward, backward, left, and right. There we go. So, okay, actually, I'm going to change this back to that because I don't want them to be like that. Okay. Don't know why I did that. I guess I just had a fault lapse. But anyways, now we can get back to implementing this. So, first off, if facing direction is equal to forward, so therefore that means we're facing forward, then we're going to initialize objects to a new rectangle. First two wait, no, not new rectangle. What am I saying? New main dot rectangle collide. Now, first parameters will be our x and y. Second parameters be a little bit different. So they're going to be based on our x and y. Now, first off, if we're facing forward, then the x-coordinate really should be the same. So we shouldn't need to move on x. Oh wait, hang on, am I thinking of that backwards? I am. I'm thinking of OpenGL vertex coordinates. Okay, yes, we will need to change x, I'm sorry. We're going to increase x by size. And to be more official, we can just do size. It's the same difference. So, x will just be increased by size, and that way it's encapsulating our width, and our y will increase by our attack range. And there. That way, we're essentially, if this mouse cursor is our current position, first off we'll go x to encapsulate our entire width, and then we'll go forward by however far we can attack. So it makes sense. Now we just need to do this for every direction. So I'll just change this, and now it'll be if direction equals backwards, if direction equals left, and if direction equals right. I'm also going to change all these to else ifs, because that way it saves us a couple of Boolean calculations. Won't do that much, it'll just fix. But, you know, it makes it a little bit cleaner, I guess. So, now if we're facing backwards, it's going to be exactly the opposite. We're going to test what's behind us. So we'll do y minus attack range. Now, if we're facing left and right, y is what's going to be our size. And I believe left will be x minus size. And, not size, x minus attack range. And right will be x plus attack range. And again, it's the same system we did before. So, yeah. Same logic, except this way it should be facing every direction. And now this should set objects to... Hang on, what? This should set objects to every game object that's within our attack range. So that's step 1 done. We now know what objects are within our attack range, but we don't know if we can attack them or not. So that's going to be our next challenge. So, how are we going to tell what's an enemy and what's not? We're going to make use of our ID system. So first off, I'm going to go to the enemy class itself, which is right here. And in my enemies constructor, I'm just going to set type equal to enemy ID. And now this doesn't exist yet, but I'm going to create it in my game object. And since our inheritance chain leads us from game object to enemy, it'll still have access to this. So, in here I'm going to create a public static final int enemy ID equals tree. There. And now I'm actually going to reorganize these because I think it makes more sense like this. So yeah. I think, it makes more sense if they're in order. So now item ID, player ID, and enemy ID. Simple enough. So now all of our enemies have their own unique ID. And what this means is we can now test if the game object is an enemy. So first off, I'm going to create a new array list. So, array list of game objects called enemies. And this list is going to... first I'm going to go through every game object. So for each game object, G-O-N objects, if go.getType is equal to enemy ID. So if it's an enemy, then we're going to add it to the enemies list. So enemies.add geo. And this way we are just separating every object that's an enemy. So for each, that's giving me an error because that can potentially not be initialized. Okay, fine, I'll just initialize it to a new array list of game objects. It will be initialized, but Java wants me to manually initialize it. And now here I'll also need to do that, so again, equals new array list of game objects. And now we have a list of all the enemies. And just to make this a little bit more obvious, I'm going to actually comment this method because it's getting a little bit complicated. And I might even divide it into separate sub-methods later on, but for now I'm just going to comment. So, here is where we find objects in attack range. Excuse me. How should I say this? Okay, this is where we find objects in attack range. You know, I just put everything under that comment. Okay, now we find which objects are enemies. And once we're done finding everything as an enemy, what we can do is we can first test if enemies dot size is not equal to 0. Excuse me, I should actually just say greater than 0. That makes more sense. So if it's greater than 0, then we'll go into here. And this is where we will actually do the attacking if it's not there is any enemies. If there aren't any enemies, we just end the attack method because we couldn't attack anything. There's nothing there. Now, if there are enemies in the attack range, the very first thing we have to test is if enemies dot size is greater than 1. So if there's more than one enemy in our attack range. Now, the first thing I'm going to do here is I'm going to set enemies... Excuse me, I'm going to create an enemy target. And if enemies dot size is greater than 1, then we're going to do something. Now, if it's not greater than 1, then that means there's exactly one enemy in our attack range. And what that means is we can just set target equal to enemies dot get at index 0. Whatever enemy is at index 0. And actually, I should change this to an array list of enemies, because that just makes more sense. And in here, I can just cast it to an enemy. And there. I think that makes a little bit more sense. So there. If we only have one enemy, then we're just going to set our target to whatever the enemy is. And then down here, we're actually going to attack it. Attack the enemy. So, in here, if enemies.size is greater than 1, well, if we have more enemies than 1, then what I'm going to do is I'm just going to set target equal to enemies.get0. So actually I can just do that in any case, so I'm going to move that out here. So I'm going to initialize it to that, and if we have more than 1, then for each enemy E in enemies, then what I'm going to do is I'm going to define which enemy is closer. So if util dot dist, so the distance between rx, ry, and enemy dot get x, and enemy dot get y. And do I have one more between parentheses? No, I do not. So if the distance between us and the enemy is less than the distance between us and our target, it should be target.getx. .getx, where's getx? There we go. And target.gety. There we go. So if the distance between us is less than the distance between us and our target, then target equals E. There we go. Easy enough. Now I can delete these parentheses because I don't need them. I should delete these parentheses too, but I think that makes it look confusing, so I'm going to actually put those back. And yeah. I actually think that it looks confusing without those, so I'm going to put those back as well. And now, in here I can just put a comment that says find closest enemy if one exists. And then, right here, we finally have enough information to attack the enemy. And actually, to save some code, I can initialize it right here. So there. Now, attack the enemy. So, how do we attack the enemy? Easy enough. Target dot add add a damage method. I completely forgot about that for a second. So I'm going to damage by attack damage, which we need to create. And this is our amazingly complicated attack method. But in theory, it should work. So here I'm just going to create another variable for attack damage. So private int attack damage. And in here I'm going to do attack damage. I'm going to set it equal to 1. And I believe that's almost everything I want to do. What I'm going to do is I'm going to change this to... I'm going to change this to print. And what I'm going to do is I'm going to go down here and just say system. And I'm going to print a space, a colon, and then I'm going to add target.get current health. And this way, we'd know how much health the enemy has. If that even exists, of course. So, I'm going to change this to print ln. Or wait, am I? Yes, I am. Okay. And then after here, if we don't have any enemies, what I'm going to do is I'm going to print out system.out.println. Come on, I wanted to finish this already. If we don't have an enemy, we're just going to print no target. So if we have a target and we actually damage something, then we're going to print out what their current health is out of their max health. So out of target.get max health. Otherwise, we're just going to print out no target. And we're going to change it so the enemy does that too. So now we can sort of see the combat happening. Even though it's not really very visual yet, we at least will be able to know it's working. So I believe I had a commented line of code, now it's somewhere here. Or was it in the Cookie Monster? It might have been... I had thought I had a commented line of code out here somewhere, but okay. Okay, so I'll just create it then. So system.out.println. We are hit. And then I'm going to add get target dot get current health out of get target dot get max health. And there, now we can finally go in and test to see if this code works. You ready? Okay, so I'm going to hit play, or the run main project button. Looks like a play button. And to start off, I'm just going to hit space. We're attacking. No target. So that's working. Now, we're attacking no target? Okay. So it looks like it can't find our target. Our enemy can certainly find us, though, so... okay, so we have a bit of a problem. We aren't able to find our target. Now, I'm going to debug this and see where I went wrong, because all my logic is telling me that this should work, so one moment. Alright, I'm back. As it turns out, there are two very simple things that were causing the problem. First off, in the enemy class, even though we were setting the type to the enemy ID, which I deleted, but the problem was, in our Cookie Monster class, when we are initializing it, what's the last parameter? It's the ID, and we set it to 0. Look, this is the method, into type. It's overriding what we had. So, what I'm going to do is I'm going to override this method. I'm going to give it to the enemy class. And in here, what I'm going to do is I'm going to change the init method. I'm going to delete this parameter and change it to this dot. Actually, I'm going to keep it. Why not? But no matter what, I'm going to set type to enemy ID. And I'll just do @override. And there. That way, our Cookie Monster class, even though we're passing in 0, it's not going to matter. It's going to be classified as an enemy anyways. So there. That fixes the first problem. Second problem, this right here. I had this to x1 minus x2. That's backwards. It should be x2 minus x1. And similarly, this should be y2 minus y1. And that was it. That's all that was causing the problem. And now if we run, it's going to work. So we can battle our enemy and lose because our enemy attacks much, much faster than we are. And we're trying to attack, we're already long dead. But since we can't die, we kill the enemy anyways. Why is the enemy attacking so fast anyways? Isn't the delay the same? New delay, 500? That's interesting. That's very interesting, in fact. I don't see why it should be attacking us if the player has the same thing. Oh, it's probably something silly I'm just forgetting to consider. Let's try setting it to 200. I just want to play around with this a little bit. Now we can try attacking the player. No, why is it not? Oh, wait. Oh. It didn't show up the output for some reason. So now if we try attacking the enemy... Oh, we just barely lose. That's okay, we can increase it. So, do not save the output. I do not wish to save the build output. Let's set it to 100. And then we're going to find where we did that. So, 100... Oh, I'm not close enough to the enemy. That's a problem. And we win. Yes, victory for us. But, yeah. We're attacking 2? Why is it saying 2? Do I have an elusive print statement that I'm forgetting about somewhere? I probably left something somewhere. Ah, right here. I was printing out the size of the objects array. Forgot to delete it. Okay. Now let's find where that extra delay is coming to 200. First off, if I increase this, does that have any effect on the rate we're attacking at? Oh, wait a second. I bet you I'm changing it in the Cookie Monster class. Am I correct? I am correct. Okay, so that's what I was forgetting to consider. Okay. Well, simple enough, but our player's attacking on 500, so, yeah. And there we go. We can now fight our enemy. And I'll do it again just because it's fun. And nope, I want to see the output. And we're going to lose. But, oh, yeah, he's bad. I cannot win. Oh, well. Why is it still at no target? Because I'm not facing the enemy. Of course. And we lose, but we managed to kill him with only negative 30 out of 10 health. Amazing. And I'm actually going to call the video here, though. Although I did want to do equipping things in this video, the problem is that's actually going to introduce a lot of issues that it's going to take way longer than the couple of minutes I have left, so I'm going to call it here. Hope you enjoyed, hope you learned, hope you enjoy fighting your enemies to the death as much as I do, and see you next time, even though this is a shorter video. So,